All right, so this one is just going to kind of have us put this stuff that we learned together. So this would be a really good one to pause and try on your own. You're going to start by filling in the missing parts of the table, and then based on that answering B through E. So give it a pause, and then come back and make sure your solutions are lining up with mine. All right, so filling in this table, right, we want to pay attention to the totals. So first of all, let's do this one over here. This is easy because this is me taking all these and adding them together. So 17 plus 70 plus 10 plus 28 is equal to 9, 10, so 125. So I can put 125 here. And by the way, I guess before I had you pause, I didn't properly introduce the example. We're considering this table from the U.S. Census that reports on the attributes of highest level of education attained and marital status. And understand the reason that we're working with these contingency tables is we are wanting to see if there's relationships between different variables, right? Marital status and education level, right? Is there any connections there? All right, let's see. How about this one? So we know that it all has to add up to 112. So if I take 112 minus 17 minus 27, then that should give me 68, right? And that would be the number of, sorry, let me backtrack there because that doesn't look like a 6 at all. But the number of people who have never been married, because that's what single means in this particular table, and whose highest education is high school. All right, now that I filled that 68 in, I can now fill this one in. So take the total of 397 people with a high school education and subtract off 68, subtract off 240, subtract off 59, and what you get there is 30 people left over to be in the widow or widower category. All right, this one here, the 143 total people with a college education or higher. So take away the 27 who have never been married, take away the 15 who have been divorced, take away the 3 that are widowed, and you will get the 98 people who are married. We can add all those up to get the total number of people who are married. So 408. We can add up 28, 30, and 3, and that's going to give me 61, the total number of people who are widowed. And then the last part is the grand total. And let's just understand that it doesn't matter, right? If you want to add up the different marital statuses, you can do that. Or you can add up the different education levels. That would be okay too. Either way, you'll get the same answer of 665 people. And so that's going to be my grand total. All right, so now we're going to go through and answer these questions. So part B says, what's the probability that a randomly selected person is married and has a college education or higher? Okay. Now remember how we talked about we're going to be really careful about the wording. So let's look at who we're asking, right? Imagine these 665 people in a room once again. So who are we asking? A randomly selected person. So we are just grabbing a person. And we're asking, are they married and college education or higher. So if we're just taking a randomly selected person, right, then that's a total of 665. So we've got to find, okay, married and has a college education or higher. So here's our married column. Here's our college education or higher. So that would have to be these 98 people that we calculated a little bit ago, right? So that's my top number here. And I punch that in a calculator, and that rounds to 0.147. All right, so let's try part C. What proportion of respondents with less than a high school education are divorced? That's our question. So what proportion, what does it say? Of respondents, but careful, is it of all respondents? Of all respondents with less than a high school education. So this whole business here is who we are asking, right? What proportion of respondents with less than a high school education? So in other words, we're in the room, we say to the group, okay, show of hands, who has less than a high school education? Okay, they all raise their hand, and then you say, okay, now keep your hand up if you're divorced, right? So it's only out of those with less than a high school education, not out of the total number of people. And we can see, of course, that 10 of them are divorced. So we get 0.08. Again, that's what we refer to as a conditional probability, right? We know the condition of the person is that they have less than a high school education. We know that before we even ask our question. All right, part D, what are the chances that a randomly selected person either has less than a high school education or is divorced? Okay, what are the chances that a randomly selected person, we don't know anything beyond that, right? Less than high school education, divorced, those are both things we're asking about, okay? So less than a high school education, well, we know that there are 125 of them, right? And again, this is going to be over the total, right? Because I have not specified that I know anything about this person yet. It's a randomly selected person. So 125 have less than a high school education. All right, how many people are divorced? Again, how many out of the total are divorced, right? Not out of the high school education, but how many out of the total are divorced? Plus 84, right? Okay, anytime we see this or, and we're adding groups together, we better make sure we haven't double counted anybody. So we have to ask ourselves, when we had the less than high school education raise their hand, and 125 people's hands went up, and then we asked the people who were divorced to raise their hand, and 84 people's hands went up, was there anyone who raised their hand twice? You bet there was. Those 10 people we counted earlier, right? Those 10 people from the last problem, they raised their hand twice. So we need to account for that by subtracting that off. And we get 0.295. And then again, what is the probability that a randomly selected person is either divorced or has never been married? Okay, probability that a randomly selected person, okay, that's it. So again, that's out of 665 for sure. Is either divorced, okay, so divorced, again, is 84. Total people are divorced. Never been married, okay, well that's the single, right? We said single means never married. So that would be this 112 people. Now here, I'm done. I don't have to subtract off anything because this time divorced and never been married, okay, those are what we call mutually exclusive events or non-overlapping events, right? And what they tell us is that we are dealing with two things that someone could not be at the same time, right? You can't be simultaneously divorced and never have been married. That's impossible. So when we asked for all the never married people to raise their hand, 112 people raised their hand. When we asked for the divorced people, 84 completely different people raised their hand. No possibility of people raising their hand twice. So I make that calculation. 190, if I add those up, I guess that's equal to 196 over 665, which is approximately 0.295. All right, so one last example here. To look at the kind of categorical data that we're going to be looking at a lot as we move forward. And this is categorical data that we want to use to draw conclusions about important questions. So in this example, it says ultrasound improves stroke blood clot clearance. Reported on the Future Pundit website the following results of a study where a control group was given only the drug TPA in response to an ischemic stroke, and a treatment group was given ultrasound in combination with TPA. So of course a stroke is a blockage, right? And so I think the idea here is that this drug is the normal treatment, but they're wondering if they do ultrasound as well, if that's helpful. And of course ultrasound is bouncing sound waves, shooting sound waves into your body, and so maybe they're thinking that would help break it up, okay? So part A, it says, what percent of those who received ultrasound treatment had the clot removed? Okay, well here, what percent of what? Of those who received ultrasound treatment. So again, we've got this contingency table, and we are not necessarily trying to take a percentage from the whole group, we're trying to take it from the group who got ultrasound. And so that's only these 666 people that actually got ultrasound. So we go ahead and put 66 as our bottom number. What percent of them had the clot removed? Well, 25 of them got the clot removed. And so that is about 0.379. And of course they asked for a percent, so we'll say 37.9%. All right, what percent of those who did not receive the ultrasound treatment had the clot removed, right? So out of the control group of our experiment here, well, of those who did not receive ultrasound treatment, so that means we're not talking about all 126 people in the study, we're talking about these 60 that got only the drug. So we have 60 in the bottom of our fraction there. And only 7, right? Only 7 of them had their clot removed. And so we get 0.117, which is 11.7%. Now, with our numerical data, we went to great lengths to find different ways of displaying our data. And we can do that with categorical data too. And so we do so with a bar plot often. It's not the only type of plot you can use for categorical data, but it's nice. And so this labels it as, okay, if they just got the TPA drug, or if they got TPA and ultrasound. And this means that the clot was removed. And so you can really see that the 37.9%, right, the white part is 37.9% of the total. And it certainly looks like this white part is about 11.7% of the total. That seems right. All right, so finally, here's a question that is going to springboard us into our next chapter. So the question is, do you think this study indicates the TPA and ultrasound, so the treatment, actually has a better outcome than TPA alone, so the control, for the whole population of stroke victims? All right, so we collected data on these 126 people, right? And presumably randomly assigned them one treatment or the other. If it was a truly randomized experiment, you'd have to randomly assign them. If they didn't randomly assign them, then it would have been not an experiment. It would be kind of what we call a quasi-experiment, but it would not be able to establish causal relationships. But here's what I really want to focus on. On the one hand, it looks like there is a big difference, right, in the percent of successes in one group versus the other. Big difference there. On the other hand, even if there weren't any difference at all in the treatments, we wouldn't necessarily expect these two percentages to have come out exactly the same, right? Because we know that in real life there's just randomness, right? So the question becomes, how can we tell if something like this discrepancy in the percent that had their blood clot actually cleared, how can we tell if that is the type of difference that is likely to happen just kind of randomly versus that kind of difference strongly suggesting that this, that including ultrasound would really be beneficial to patients, right? So, did this happen by chance? Or is it likely that it happened because there's actually a difference in effectiveness of the treatment and the control? So that's the big question. We're not going to answer it right now. I think it would be good for you to just kind of think about, what do you think? Do you think that's enough of a difference to justify a conclusion that ultrasound should be added? Okay, but we're not going to answer that now. But that's what we're going to be focused on in Chapter 2, is figuring out how do we answer that question with confidence.